So now I'm considering a full projectivity without translation. So let me explain what the components of the simulation are. I have an ABC family, okay, which is interscribed between two circles, this outer circle here and this inner circle here. So this is a Chapple Porism, ABC of triangles, right? Now what I have here is also the projective image of ABC under this matrix here, okay? So it's a 6-entry matrix. The translations are 0. I can set the values of the 6 entries in the matrix, and then I got A prime, B prime, C prime, which is a projected image of ABC. Now what I'm doing here is I am studying the locus of, for example, the barycenter x2 of A prime, B prime, C prime under the full motion of the base bicentric family, right? So I'm getting an ellipse there. And what this video is about is to know if there are any invariants over these loci as I move the center of the caustic of the bicentric on a circle. So a circle meaning I'm preserving the distance between I and O, so I'm guaranteed to preserve the Porism. Okay, now what's happening to the family of loci of A prime, B prime, C prime, and in this case x2. Now what I'm tracking here is the area of the loci and the eccentricity of the loci. So the area being proportional to the product of the semi-axes, and the eccentricity being a function of the ratio, okay? So let's go ahead and animate I. Now you can see here that when these elation entries, okay, the bottom M31 and M32 of my projection matrix are non-zero, the set of loci only preserves the eccentricity. If I make those entries be 0, as in the previous video, you preserve both of them, you conserve both of them, okay? But if they are non-zero, okay, whatever they are, okay, x2 is only preserving the eccentricity. So it's no longer a simple translation. I think this is the more generic case. Let's look at what happens with x3. Now I have the circumcenter now being plotted, and you can see here that it preserves neither. So when those entries were 0, for example, like this, it did preserve the area. So for a simple affinity, the set of x3 loci preserves the area, but if it's a full-on perspectivity, it doesn't preserve either one. Okay, now let's look at x4. In a full-on perspectivity, just like x2 did, the set of loci of the orthocenter preserve the eccentricity. Of course, if I take it to 0, and I make this be just an affinity, it continues to preserve the eccentricity. It seems that x4 is preserving the eccentricity no matter what the elation is, those two bottom entries in my projectivity matrix. How cool is that?